Okay guys, by request, we're gonna talk a little bit and I'm gonna walk you through what goes on in my head when we're messing around with these graphs and transformations. It's vital that you know those parent functions and what they look like. If I say sine, it should already be going through your head that it's 0 at 0 and it ends at 360, halfway in between at 180 it's 0, up to 1 halfway in between there, which puts that at 90, and then down to 1 halfway in between there, so that we know sine. Okay, same reasoning. When we say cosine, you should be thinking 1, 0, -1, 0, +1, so that we get the same curve, it's just kind of phase shifted over a little bit. That's where you're going to start every single time. So if I'm given an equation, I'm going to identify transformations and then do that to my parent function. I see that it's cosine, so I'm going to go ahead and mark on here what we're used to working with to get my framework laid out. So I know this is where we're starting. Okay. This 2 vertical stretch tells me my amplitude now. Instead of just being 1 from center to extreme, we're going to go up to 2. So what I'm going to do is I'm going to kind of bracket that off a little bit. Kind of gives me an idea of where my curve's going to move to and from. But then when I see this -1, that means the whole thing's been shifted down 1 unit. So we're going to move that over, make it a little bit darker. And in essence, we just moved our x-axis down as well. So I'm going to include that lightly in here as well. And I'm going to get rid of my original 2 lines because it's confusing enough as it is without that in there. Okay? If I didn't have any of this going on in the middle, then I would know my 1 is going to be here, my -1 is going to be here, my +1 is going to be here. The whole thing's just been stretched. I don't even have to think about the fact that we've moved it down 1 or up 2 because I've already drawn out my boundaries. But we do have this mess in here that we have to deal with. The first thing we want to understand is this 2 theta. So that means I can see 2 cycles in 360 degrees or 2 pi, which means the period now of 1 is half of 360 or 180 degrees, which is just pi. So what that means is I'm going to take my whole function and it has to happen in that smaller space. So we're going to start at 0. We're going to end now at 180, and halfway between that we're going to drop to my minimum point there. Curves down and back up. Remember, basic transformations, plus on the inside means we move to the left pi over 4. So I'm just going to take each one of those. My graph is labeled in pi over 4 increments, so my points are all just going to shift to the left. And all I have are my max and my min. I want to clean that up a little bit more because I know that halfway in between is where it's going to hit my zeros. I want this to be as accurate as possible. And so here's 1 period of 2 cosine of 2 theta plus pi over 4 minus 1. We'll just continue that on. To fill however much space we have. And back through the other side. So we've graphed the whole thing in that one space. Now, what if I've got a graph and no equation? Okay, well the kicker is that looks like sine and it looks like cosine. So I'm going to always ask you to write both. We always want to look at where it starts from when x is 0. So I'm going to highlight the axis. That's important. Certain things are the same no matter what, right? Vertical stretch always comes in front. Vertical translation always comes out at the end. And we can get that kind of information by looking at where the top of our function is and where the bottom of it is. Okay? It runs from 0 down to -4, so the middle of that, or my translated axis, happens here at -2. So regardless of what my function is, I know that at the end, it's going to say -2. Okay? I like sine, so we're going to start with sine. If I start at 0, and sine's supposed to start at 0, I haven't shifted to the left or right at all. So I know I've just got sine of whatever's going on here with x, but there's kind of a +0. You don't have to write that down. I'm going to put it there to hold our space. Now, how tall is our function, my amplitude? Well, it drops down 2 units and it moves up 2 units, so there's a 2 here. I'm looking at sine, so I want to find one complete cycle. So from 0 to 0, it went down first, which tells me it's been reflected. I need to make that negative in front. How long did it take it to do that? Well, from 0 to 720 degrees. This whole space was 720 degrees to make one cycle. That's twice as long as normal, which means if I look at just my 360, I know I can only see half, which tells me x over 2 is what goes inside parentheses. So my equation in sine is -2 sine of x over 2 minus 2. Well, we're supposed to write that in both sine and cosine. What's the same? Well, the -2 is going to be the same. The period's going to be the same. And the vertical translation is going to be the same. All of those things carry over from sine to cosine. Now, we need to find a chunk that has our representative cosine pattern. It starts at 1 here, ends at 1 there, drops to a minimum here. So I'm going to add this layer. Okay. Still takes the same 720 degrees. It's just been shifted back to the left. How far? Well, that's 180 degrees, which means plus 180 on the inside. That's the only thing that's different when we're writing cosine.